Okay, let me give you guys another example. So in the previous example, I gave you something like this. Y squared plus x squared equals 2. And then that gave us a perfect circle. But then for some reason, if you stick this xy into here, for some reason it skews the circle to one side. So if you get a graph plotter and plot this, it will then give you this. Well, our aim in this video is to try and draw a tangent line that just touches this at x equals 0. So our aim here is to draw this tangent line. Our aim is to come up with an equation for this tangent line. But then for us to come up with the equation, we will need to know the gradient at this point here. Once we know the gradient, then well here we know the intercept, so we can easily come up with an equation for this line. Well, our aim here is to later to draw this straight line here, this tangent line that just touches at x equals 0. Okay, so to do this here, we need to know the gradient at this point. So let's try and differentiate this. Okay, so start out with your equation here. So you've got one thing equals another thing. So whenever you have one thing equals another thing, remember whenever you have an equation, you can add equally, you can take away equally, you can times equally, you can differentiate equally to both sides. So you've got this thing here at the moment, differentiate both sides. So that will then give you this. Okay, and whenever you try and differentiate a complicated bubble here, you can actually break into this. One of the theorems allows us to do this. Okay, so that will then give you this, meaning that if you're trying to differentiate something complicated, you can just concentrate on differentiating this. You can just concentrate on differentiating this. You can just concentrate on differentiating this, and then right at the end you can add them all together. But when you come to differentiate this here, let's not bother with these two steps. Let's just do it in one go. Okay. So here, so you start out with your equation like this. Okay. Now differentiate it in one go. So here, remember here that y is a function of x. Remember that this y here is a function of x, meaning it has x buried somewhere inside there. So when you differentiate it as normal, which is so you can imagine this. Remember, y is a function of x. Y is a function of x, meaning you can imagine it like this: 2x plus 3. So y is the bubble here. So it's a function of x. It means that it has x buried somewhere in there. So when you differentiate this, so this is your y here. This is the bubble, and then you've got your squared here. Your squared here. So when you differentiate this here, you would differentiate the bubble, which is 2 bubble intact, and then you would times the differential of the bubble itself. In this case it's 2, but we could just leave as dy by dx here. So my point here is that when you differentiate this here, differentiate it as normal, which is 2y here, but then because y is a function of x, it contains x, you've got to times by dy by dx. Okay, now differentiate this here. X is just on its own. It's not a function of anything. It's on its own. So when you differentiate it, it's just simply this. You don't need the dy by dx here because it's not really a function. Well, this is a function of x. It has x contained in there somewhere. Well, anyway, when you differentiate this, it will give you this. Now this bit is quite tricky because you've got one block multiplying with another block here, and this block here contains x. Remember, y is a function of x. It contains x. So it's like you having this here. You've got one thing. Hang on. You've got one thing, and then you've got to you've got so it's like you having this block here. That's this block here, and then you've got another block. But this block here also contains x. So here you've got to use a product rule here. You've got to remember the product rule is that you differentiate one thing, leaving the other thing the same, and then you plus, and then you leave the first thing the same, and then you differentiate the second thing. So when you differentiate this, okay, so differentiate the x, that will give you the y, okay. So yeah, so that will give you this here, and then this plus here is this plus here, and then you leave the x the same, and then you differentiate the y. So that will give you this. But then because y is a function of x, you need to times dy by dx. So when you come to differentiate when you come to do implicit differentiation, every time you have a y, you need to times by dy by dx. So basically, this whole thing here becomes this. Okay, because yeah, so this here, well, this whole thing here becomes this here. Okay, and then hang on, and then what? Oh yeah, and then here's just a trick. It's just a new method of doing things. You're trying to get dy by dx on its own. So at the moment you've got this block plus this block plus this block plus this block here. Get rid of these two over to the other side, and then later factor out the dy by dx. So take away 2x, and then take away y. That's this thing here. That will then give you this. Okay. So now you've got now you can imagine this block times this block plus this times this here. This is in common. This is in common. Factor out the dy by dx. That will give you this, and then so then it will be this block multiplying with this block here. So now divide both sides by this bit here. That will then give you dy by dx on its own. So now that you know dy by dx, suppose we know that it crosses this point here. Okay. The reason I know is because I looked on the graph plotter. So this point here is given to us. It's given us this. Okay. So you would put this into the equation here. Sorry, this. Yeah, you would put this into the equation, and then dy by dx becomes this here. And then, sorry, I'm rushing because the battery on my computer is running low. So dy by dx gives you this. So the gradient is negative a half. So now that you know the gradient is negative a half, and you know it crosses this point here, so the intercept is this bit here. So the equation for this line here is y equals negative a half x plus, okay,